Okay, so now we're going to work the molar volume multi-step problem. So we're going to be going all over the place using our double mole diagram. So let's take a look at number 1 through 7. So it says, number 1, we are going to it says all of our substances are gases at 273 Kelvin and 101.3 kilopascals. So that means we are at standard temperature and pressure, and we can go on and use our mole diagram for conversion. So we're going to be converting 1 through 7 over to our volume at STP, or converting over to our number of liters. So number 1, we're finding our volume, or liters, and we are working with diatomic nitrogen. What do we know about nitrogen? We know we have 3.0 times 10 to the 23rd molecules, MOLCS, of diatomic nitrogen. If we want molecules to cancel, we know that's going to go in the bottom of our equality. We go to our double mole diagram, and we're starting here at our number of moles of, or our, not our number of moles, excuse us, but our particles or our molecules, and we're going to go to moles, because notice we can't go moles up to volume. We have to stop at this place first. We have to pass through this city, like if it's a map. So moles will go in the top. Just like before, the number 1 goes with our number of moles, and we use Avogadro's number for our number of molecules. So molecules, they cancel out. In our next equality, our step, if we want our number of moles to cancel, moles will go in the bottom. And since we're going moles up to our volume, liters will go in there. And our number 1 will go with our number of moles. Moles now cancels. We're in liters. What do I put with liters? Well, we look at our mole diagram and we're traveling along what we call 22.4. That is what we're going to use because we pass it going from moles up to our volume. So we're going to multiply 3.01 times 10 to the 23rd times 1 times 22.4 and write that answer down. And again, I know that we can reduce some of these equalities, but that's not always going to happen. So I'm going to show you again. We multiply everything on the bottom. So we're going to do 6.74 times 10 to the 24th divided by 6.02 times 10 to the 23rd, and we get 11.2 liters of nitrogen. So number 1 is going to be a model for 2 through 4. Now number 5, we are in grams. We're starting with mass, and we're going to be going to volume. So again, how many liters? And specifically, we're working with oxygen gas. And we know we have 32 grams of oxygen gas. Just like before, if we wanted mass to cancel, we would put grams down here in the bottom. And the unit that we're going to will go in the top. So we're starting here in mass, and we're going mass to moles, moles up to volume. And when we go from mass to moles, we're going to use our periodic table. So we'll put moles of O2 here. Again, the number 1 goes with our number of moles. And oxygen, it has the mass of 16, but notice it's O2. So we need to take 16 times 2. That gives us 32 grams. So now our grams of oxygen is going to cancel out. Now we're going to convert our moles of oxygen. So moles will go in the bottom. So moles will cancel. And where are we going to? Well, since we're going to volume, volume or liters will go in the top, and we're going to use the 22.4 to fill in the equality. So 22.4 liters will go in the top. So I know we can reduce some of this to get our answer to 22.4, but again, they're not always going to work out this simple where we can reduce to get our answer. So we'll take 32 times 1 times 22.4, and we end up with 716.8. And then we take 32 times, oops, I forgot to put my 1 in there, times 1, which is 32. So then we're going to take 716.8 divided by 32, and we get the 22.4 liters of oxygen. Now, if you can reduce, that's great, but they're not always going to be that easy to reduce and work out. So number 5 is a model for 6 and 7. And then we go to number 8. So with number 8, we want to know what is the mass in grams. And we are specifically working with diatomic nitrogen. What do we know? We're given 44.8 decimeters cubed. Remember, that's the same thing as a liter. So take your dm cubed and just change that to a liter. If you want liters to cancel, liters will go in the bottom. And let's go to our mole diagram. So when we look at our mole diagram, we're starting here at volume, and we're going to drop down here to moles, and then we go moles over to mass. So reverse the last problem we just worked. So when we go volume to moles, we're going to use the 22.4. And like I said, since we're going to moles, that will go in the top. And the number 1 will go with our number of moles. Our volume is canceled. We're now to moles. If we want moles to cancel, we'll put moles of N2 in the bottom. They cancel now. Looking at our mole diagram, we're going to go moles over to mass using your periodic table. So our number 1 will go here, and we are going to be looking at our mass of diatomic nitrogen. So nitrogen has the mass of 14. So since we have 2 nitrogen, we have to take 14 times 2, which is going to be 28 grams. And we're going to take 44.8 times 1 times 28. Write that down. And we'll take 22.4 times 1, which is itself. And we're going to end up with 56 grams of diatomic nitrogen. So number 8 is going to be a model for 9 and 10. So let's take a look at number 11. So with number 11 through 13, we're finding our number of molecules. And we are specifically working with oxygen. So this time, we are given 11.2 decimeters cubed or liters of oxygen. If we want our volume to cancel, we're going to put liters down here in the bottom. And we're going to go to our mole diagram. So basically, we're going to start off here at liters. We're going to go 2 moles, and then we're going to end up down here at the bottom with our number of molecules. So we're going to go volume or liters to moles using the 22.4. And moles will go in the top because that's the box we're traveling to. Liters, cancels, put in the number 1 for your mole. If we want moles to cancel, moles will go in the bottom. And looking at our mole diagram, we're going to go moles down to your number of molecules using Avogadro's number. The number 1 will always go with our number of moles. Avogadro's number will go up here with our molecules. Moles cancels out. So we're going to multiply 11.2 times 1 times 6.02 times 10 to the 23rd, and we get 6.7424 times 10 to the 24th. We'll take 22.4 times 1, which is 22.4, and we're going to divide. And we get 3.01 times 10 to the 23rd molecules of oxygen. So again, with these, make sure that you show your work, you label your answers, and you circle your final answer because it's easier to grade that way. Number 11 is going to be a model for 12 through 13. Let's take a look at the mole diagram. This is really, really important. Some other terms that we can use for mass, especially when we start working more word problems out. Again, if they mention formula mass or molar mass, like what's the convert to the formula mass or convert to the molar mass or whatever, that is this box right here. It's referring to your grams. The other one, it's a little hard to see because of the shade. Let me see if I can get it to move up a little bit. Okay. Formula units. Okay, so formula units will be another term for number of particles, atoms, and molecules. Okay, so formula units is the same thing as starting down here and converting using Avogadro's number to your number of moles. So I just wanted to give you the heads up on that. And I will let you abbreviate formula units as long as that's what you mean by formula units. Okay. So that will conclude this video.